Definitely got better with one or two exceptions. And the big thing is that are you comfortable now that you've been through where you saw your mistakes and now you're like, okay, I can get that right tomorrow? All right, that's what we want to make sure of. Are we good on the y-intercept? Okay. Okay, now, I think today's do it would be difficult for a lot of you guys because you haven't seen a question like this. And sometimes I like to give do it's where you've never seen it before. And let's see, hey, maybe somebody can figure it out all on their own without even being taught. That's really cool. And if not, it's not like it's being graded. It's really not a big deal. The fact that you tried it and maybe messed up will have it be more real to you. A good example I can think of is my grandfather and how he taught me how to put windows in. The first house I owned, I had a whole bunch of Anderson windows sitting in the garage for a really long time, and I didn't put them in. I didn't install them and take the old windows out and put new ones in for a very long time. And my grandfather came up to me one day. Now, my grandfather did not get his high school equivalency diploma until he was in his 50s. He had quit high school during the Great Depression so that he could help his family. His father broke his back, and they were going to lose the house. So he actually went to work so that the family would not lose the house. So I was the first person in my family to ever go to college. And I have two degrees. I have a degree in math. I also have a degree in physics. And he comes over the house one day, and he says, how come those windows are still sitting in the garage? I said, I don't know how to put a window in. I can't do that. I don't know. I can't do that. I'm waiting for my brother-in-law, Jeff, to help me. And he looks at me and he goes, he says, don't give me that. He says, you have a degree in physics. If you have a degree in physics, you can put a window in. He says, I'm going to be at the house on Saturday. Clear your schedule. I'm going to teach you how to put windows in. So at this point in my grandfather's life, he's in his mid-70s, late 70s. He comes over to the house and he says, okay, let me show you how to take a window out. So we took out a bunch of windows on the first floor. And he says, okay, let's put one in. So we put one in. And then he says, I'm going home. He says, you have until dark to get the other windows in, and I'm not helping you. So it was kind of trial by fire. And what I learned is that maybe the next window I got in wasn't the best, and maybe the third window wasn't the best. But by the time I got to like the fourth or fifth window, I was rocking those windows. I knew what I was doing. So I very much believe that the best way to learn is to just roll up your sleeves and get to work. You learn by doing, and it's okay to screw up. It's okay to make a mistake. And then, based on the mistake that you've learned, you learn from it. For instance, of all the people in this class, the number one person on the Regents exam that I pick to get any question about a y-intercept right is Yasmin. Because the kind of mistake she just made, she will remember that for the rest of the year. She will never forget. And am I right? Is it really simple? Yeah. Okay, and that's not to say she's bad, because you will all have a Yasmin moment. Every one of you is going to have a Yasmin moment. Okay, and it does not make you bad at all. I said yesterday that what I really look for is when I look at these columns, I want to see improvement. So let me tell you how you did as a class, and I do not read these in order because I don't want to embarrass anybody, so I just kind of hop around. These are all the grades that did not have 100 yesterday, okay? 90, 100, 50, 88, 70, 75, 95, 75, that was a downer. 95, 100, 90, 95, 58, 75, 75, 100, 95, 100, 95, 100, 95, 100, 88, 100, 55, 75. So one kid went down, and I'm going to call that a mental spasm. Those things happen every now and then. And everybody else went up. And that's what we're looking for. We're looking for improvement. We are not looking for perfection. If I look for perfection, I will continue to look for it till the day I die, because I'm not going to find it. Okay? What I look for is people who are humble enough to say, I don't need to be perfect. And when they mess up, they turn around and say, hey, rather than complain about it and get nasty and stuff, they just say, what did I do wrong? Where's my mistake? Let me straighten this out. If we're doing that, we're in great shape. Okay, so here's today's lesson. I'm going to just scale this down a little so I can see it better. And it says, draw a graph of the following rates of change over the given intervals. And what we're going to talk all about today is more piecewise linear functions. Now, up until today, what I've been doing is giving you the graph, and then we talk about it. Yesterday we did the part about the dead body, right? Or I draw the picture and I ask what's the rate of change from here to here and so on and so forth. Today we're going to do it a little bit different. I'm going to give you a blank graph and then we're going to draw the graph based on what it's saying. And at first it probably looks really awkward, but I think you will find that this is not difficult at all. So part A I'm going to do in red. I'm going to change the colors for each of the parts. Part B in blue, part C in green, and part D in black. So back to red. Remember yesterday we talked about the differences in these notations. Now, a staple means it's allowed to equal it. And I didn't mention this yesterday, but the way I remember that the staple means it's allowed to equal it is because if you take the top of the staple and the bottom of the staple, what do you make? An equal sign, right? Okay? And in a parenthesis, you're not allowed to equal it. So if I had a graph from way back when and I said x is less than 7, it would be an open circle, shaded this way, right? 7. And if I said that x was less than or equal to 7, that would be a closed circle on 7 and arrow to the left, right? You guys remember that from last year? Okay, so we're going to employ the same technique. This would be a picture of a parenthesis, this would be a picture of a staple, because the staple's allowed to equal it. Okay. Am I allowed to equal the -3 here? Yes, so that's going to be a solid dot. Am I allowed to equal the 0? No, that's going to be an open dot. And the rate of change, which is also known as slope, is 2, and we're going to start at the point -3, -5. So here's -3, 2, 3, 4, 5. There's -3, -5. I purposely make this a filled-in dot because it's a staple here. Okay? What kind of dot am I going to finish with when I'm done? Am I going to fill the dot in, or am I going to leave it open? Talk to me. How many people vote for fill it in? How many people vote for leave it open? Excellent. We leave it open because of the parenthesis here. Now the rate of change is 2, and I go all the way until x is 0. So up 2 over 1, up 2 over 1, up 2 over 1, and then I stop. Now this has to be an open circle, and there is my first piece of the graph. Okay? I'll let you guys catch up. So now let's work it backwards a little bit, and let's see if it makes sense. Does it make sense that over the interval from -3 to 0, the slope is 2? Everybody see that? Right, you with me? Yeah. Okay, good. Now, I jump down to the point 0, 0. Am I allowed to equal? Do I fill in the circle for the beginning of this? Yeah. Yes. So I go to 0, 0, and I fill it in. Now, where do I go? First of all, what's the rate of change going to be over this section of the graph? A half, good, which is up 1 over 2. And how far do I go, or when do I know when to stop this piece of the graph? Where do I stop?
When we get to 4?
That's right, when we get to 4. I know that because it says it right there. Do I make a solid circle when I get to 4, or do I make an open circle when I get to 4? Solid, because it's a staple, right? Okay, do that on your graph. Let's see if you get that part right. Okay, up 1 over 2, up 1 over 2, and we said we make a solid circle, so I stop there. Okay. What is the next interval over which I am going to do the graph? From what to what? We're reading the green part here. From what to what? I start at 4. Where do I end when x is? Talk to me. Come on. What? 7. Very good. Don't be scared. It's okay to make mistakes. You can answer questions and get it wrong. All right, but we want you engaged. So yeah, I begin when x is 4. That's where I am here. And it goes to 7. It says start where I left off. So that's the piece right there. And the rate of change is 0. So I go all the way to 7, and I have a slope of 0. It's a staple on 7, so I fill that circle in. Does that make sense? Yeah. Okay. And now, last but not least, starting where I left off, I begin at 7, and I go until I hit x equals what? 10. Is this going to be a solid circle or an open circle?
Solid.
solid circle, and the rate of change is -3. So I'm going to go down 3 over 1, down 3 over 1, down 3 over 1, solid circle. There's my graph. Okay? Now, to have this really make sense, let's work it backwards for just a minute. Let's look at the graph in each of the 4 parts. Remember, we call this a piecewise linear function, and you can see it's broken into really 4 pieces: red, blue, green, and black. So if I look at my red section, I'm allowed to equal it in the beginning, and I'm not allowed at the end, and that's what those 2 symbols mean. Then the rate of change is 2, so up 2 over 1, up 2 over 1, up 2 over 1. That's good. Next, I go down to 0, 0. There's a little jump here. And this means I have to include the point, solid circle, include the point, solid circle, and I go until x is 4. Up 1 over 2, up 1 over 2. Now x is 4, so I stop. Then it says, starting where I left off, so that means I have to go right there on the second blue dot, go from 4 to 7, and they're both staples, so I fill them both in, slope is 0. That's a straight line, horizontal across. And then, from 7 to 10, I go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. The 2 staples mean that both of these marks have to be solid. Okay? Does that make sense? Okay. If you got that wrong, that's not an issue and not a problem. I would be stunned if people got it right. The big thing is, you know tomorrow's due, it's going to look just like that. So tomorrow you should look at it and go, ah, I remember. Just like when I had those windows from my grandfather and I said, okay, I remember. Because you got to work on it and so on and so forth. Okay, good. So now, let's go to the next segment of class. Make up an elevation versus time graphing story for the following graph. Begin. I'll give you, I'd say like, I don't know, maybe 2 minutes to get that done. This cookie was all alone. I'll take care of it for you. I got your back. Yeah. Yum, yum. Yum, yum. Miss Minushkin, I hear you like to read. I expect a good story from you on this one. A little creative. I'm a huge C.S. Lewis fan. Super huge C.S. Lewis fan. So I expect creativity on his level. I love licking the chocolate from my fingers. You like it too, you know it. You're the kind of girl who at the bottom of the crumb cake box puts it all in the corner and picks the whole box up. Unless you do that, don't you? Mm-hmm.
All the crumbs around the bottom of it, so I just like licked the whole thing.
You licked your desk.
No.
I don't question.
Oh, on the wrapper. Oh, okay. I thought they fell onto your desk. Oh, it's silly of me. You do that anyway. Yeah. Your one brother, Seth, would definitely do it. Justin would probably be smart enough to scoop in his hand. Seth would go right for the crumbs.
Zach jumped into a dirty pool for a skateboard. And he also broke my DS. It was in his pocket. It was a sad time for me.
Oh, I can believe it. Okay, who would like to tell their story? Emma, fire away.
There was a guy flying to the moon, but he hit a bird and fell into a ditch. After a few hours, he climbed up the ditch and died.
Interesting. Interesting. So he's climbing up to the moon,
He's flying.
flying to the moon. Okay, good. Does he have like a rocket jet propulsion pack on his
No,
back?
he's just flying.
Just. Does he have feathers?
No.
He's got like some really,
Like his
really.
fingers like extending and they
His
kind
like Mothman.
I don't know.
Anybody ever hear of Mothman? There you go. All right, so you know what I'm talking about. It's this guy that supposedly lives like in West Virginia and foretells all these bad, terrible things that are going to happen because he flies to a certain point and then he what?
Hits a bird.
Hits a bird. Must have been a big bird.
Yeah.
Okay. So he hits the bird and he kind of loses it for whatever, like 2 seconds or whatever, and then he does what?
He falls into a ditch.
He falls into a ditch. It's very important, the words into a ditch. Why are those words very important?
Easily goes negative.
Yeah, he gets below ground level, if you will. Did anybody else in whatever you wrote include something that suggested he goes below the ground level? Did you do that too? Okay, very good. What did yours do?
I put a man drives a car up the hill. He cruises for like 2 minutes and then he drives down into a ditch and drives back up.
Okay, so you guys like ditches. Lots of people with ditches. Okay. And then he's there for a little while and then he drives back up. Okay. Anybody else have an interesting story?
I'm almost done with it.
Oh, you're almost done with it. All right, we'll come back to you in a minute. Anybody else have an interesting story? A little creativity?
Maya.
Do you have an interesting story, Maya?
Yes, she does.
You do?
Maya, read it.
Come on, Maya.
It just kind of reminds me of what I would do if I went up 9 feet and then I just like walked for a little while and then I decided that I wanted to roll down the hill.
Okay, can you start from the beginning?
Well, a person climbs up the 9 feet and walks for a few
On level ground.
minutes, yeah,
Yeah, okay.
and then decides that they want to roll down the hill, but then realizes that there's a small valley, so they go down farther than they expected.
Do they hit the valley floor hard or is it gentle?
There's soft marshmallows down there, so
Oh,
yeah.
soft marshmallows.
Yes.
So he obviously spends a lot of time eating the marshmallows, right? Yeah, that's a given. And then he reluctantly crawls up to the top because he got to poop. Okay. Oh, you can't poop on the marshmallows. It's just not going to work. That's just disgusting, isn't it? Okay. It's like, I won't go any further than that. All right. Anybody else with an interesting story? Go ahead.
A seagull takes off and flies. It goes to 5 feet in 2 seconds, stays at that elevation for 2 more seconds, then dives into the water, grabs a fish, and walks back up to shore. Whatever, however they get out of water.
First off, there were some really cool birds. This is actually a very good story, and I do a ton of fishing. There's a type of bird called a gannet.
Oh, yeah.
Yes.
Like
You should know something about me. I'm not a big believer in the theory of evolution. Okay? I think that there's clearly this thing called adaptation. I think that's obvious. I think anybody in the world can look at animals and see that they adapt. But change from one to another, that's kind of a difficult thing for me to wrap my head around. I don't see it as something that's logical. Yes?
Like the apes turning into humans.
That would be one example. That one is actually, I don't personally believe it, but I think it's more believable than, for argument's sake, a mouse turning into a bat or an elephant. Or it's supposed to have done both. Yes, that's a true statement. Yeah. So there are things about it that I just think are very difficult to understand. Like, for instance, you don't just, hair is completely different than feathers and so on and so forth. So anyway, I don't want to get too into that. But I will say one thing about a gannet. If I've ever seen a bird that looks like a dinosaur, it's a gannet. Okay? They actually have a beak with like serrations in the beak that almost look like teeth. So they're a weird, funky looking bird, and they're very big. And they have a very difficult time walking on land. But what gannets do is they fly. I wish the YouTube worked on this. I would show you the video of them. Gannets fly like 100 feet above the water. And they make themselves into like a missile. And they dive straight into the water. And they can go down 40 or 50 feet. with a dive, and they catch bait. And then they literally fly through the water. You see, there's videos of this all over the place. They beat their wings, and then they come up through the surface, and they fly away, which is kind of what you would have here, except he's stopping at the surface. Now, does anybody here know what bluefish are?
Yeah.
Right, bluefish are nasty, right? Big teeth. My buddy watched one time as a gannet was coming back up out of the water, and the bluefish jumped up and bit the gannet. And it was holding on to the gannet, and the gannet's trying to fly, and the bluefish wouldn't let go of it. What's that?
Isn't it supposed to be opposite? The bird actually bites the fish.
Well, with most fish, it would be that way, smaller bait fish, but bluefish get very big, and they have very strong jaws. Have you seen seagulls with 1 foot? If you watch, you'll see them, yeah. A lot of times, those are seagulls that went into the water with a school of bluefish, and the bluefish grabs the foot, and then it's gone. It's okay.
What's your original story?
Well, I don't remember. I haven't done this since last year, but let's go with one here. Ready? ISIS is in the Middle East, causing lots of problems. We get in a real commander-in-chief who understands that these are psychopaths who lop people's heads off, including children's heads. So he says, enough is enough. So he sends up a drone. The drone flies at a steady height above the ground until such time as it sees ISIS, and it follows ISIS. Or better yet, let's go with a Tomahawk missile. He shoots the Tomahawk missile up. The Tomahawk missile flies across the ground. Then ISIS runs into a hole to get away from the Tomahawk missile, which they see coming. So the Tomahawk missile goes through the same hole, goes down to the bottom, goes psh, and all the ISIS people are no longer. And then, well, we're running into a problem here. Okay, the Tomahawk missile reassembles itself, walks up to ground level and goes. All right. Any other interesting stories about how we're doing with that? Okay, very good. So, listen, what we've tried to cover the last couple of days with piecewise linear functions. The big thing is, if you see a staple, is it allowed to equal it? Yes. If you see a parenthesis, is it allowed to equal it? No. So a staple is what kind of circle? Filled in, solid circle. If it's a parenthesis, it's a what? Open circle. And remember your slope, up 1 over 2, so on and so forth. Okay.
I'm still interested.
Yes.
I have to give you something.
Fire away.